Alrighty, so now, check this microphone, yeah, we're good. We're going to be talking about some piecewise functions. So for piecewise functions, here's what you need to know. First off, let's write it at the top. So piecewise functions are just what they sound like. They're made of pieces. So if you remember, if you recall, it looks something like this. The function, f of x, is going to be comprised of a couple different equations. Each one is going to be something like, I don't know, maybe 2x plus 1 here. Maybe here it's, just 5, and then here is maybe negative 1/3 x. So those are the three different equations that we're going to use, and each one's going to have a different domain restriction. So the idea being that for certain values of x, that's the function you're going to be using, and for certain other values of x, you'll use this guy, and other values, you use this one. So to show you what I mean, the first one might be something like x anything less than or equal to 4. Let's do minus 4. So minus 4. Zoom in a little bit. And then maybe this one has a domain restriction where it's for x's between negative 4 and how about 1? And then for this one, maybe it'll have a domain restriction for x's anything greater than, how about 6? So something like that. So if we want to graph this monstrosity, first thing we'll do is make that coordinate plane and zoom out a little bit. All right, so just so we're clear, this is our first guy, our second, and our third, okay? So let's go with the first, because that makes sense to me. And the idea here is we're going to take this number, negative 4, which is a right side boundary, because it's on the right side of x. Yeah, this is the right, the left. This is the right as well, although I should probably rewrite this. Let's do it where 6 is here. Left side boundary. So we're going to take that number, that negative 4, and we're going to plug it in and see what pops out. And it's going to get us the coordinate, negative 4, comma, whatever pops out. So taking that negative 4 and plugging it in, we have 2 times whatever we're plugging in plus 1. That's the equation there. And instead of x, we're going to write minus 4. So then we do some math, and we get 2 times negative 4, which is negative 8. And then we add negative 8 and 1 together, and we get negative 7. So at negative 4, we get negative 7, and that's our coordinate. We don't have any other numbers to plug in, so we're just going to plot this coordinate right now and see what happens. Because there's a line underneath here, remember we need to have this be a solid circle when we plot it. So negative 4, 2, 3, 4, comma, negative 7. 1, 2, 3, 4, 5, 6, 7. And that's where our dot's going to go. It's going to be a solid dot again because there's a line under here. And because there's no other point to plug in, we can't get another point to plot and then connect our dots. So what we have to do is we have to look at the slope here. It's 2. So from this dot, we go up 2 over 1. That's a possible direction we could go. Or we could go the opposite, back down to back 1. So the question is, here's the line 2x plus 1. Right? That's what this is. The line 2x plus 1 right here. Do we want the right side of this line or the left side of this line? And we look here to figure that out. So this says x less than or equal to negative 4. Well, negative 4 is where this dot is, right? Here's minus 4, right? Zoom in a little bit. So right here is minus 4, right there. So there's where the dot is. This says less than negative 4. So here's negative 4. Less than is to the left. So we want the left side of this line. So we want the side of this line that goes that way. Now again, it's important when you're drawing this little sketch to make sure you have that second point there so you can tell what the slope is, right? It's down 2 over 1. But the straightness of your line isn't that big of a deal. I'm not too picky on that. For the second one, we've got these two numbers to plug in. So let's do that. So we have these two numbers to plug in. So we're going to plug them in here. Now you might notice already This one had an x, so we knew where to plug in the number. We plug it in right there. But this doesn't have an x, so it's really easy to do, actually. First number we're going to plug in is -4. When we plug it in here, there's nothing to do, so we just do what it has there, 5. And 1, when we plug it in, this number, again, nothing to plug into, so we just do what it says, 5. So those are our 2 points, both of which are going to be open. And the reason for that is because they do not have a line underneath. See how before we had a line and it was closed? These don't have lines, so they're going to be open. So let's plot both of those points. Our points were -4, comma 5. That's -4, comma +5. 2, 3, 4, 5. That's going to be right here. Oh, oops, and it was open. My bad. Open circle. And then we've got 1, comma 5, which was supposed to be open. So 1, comma 5. And you'll notice these sit on a flat horizontal line right here. So because we had 2 dots to connect, we could just do that. And they were connected by a horizontal line because the equation has a slope of 0. There isn't a number next to x here because there is no x, which means there is no slope. And just like a hill that has no slope, it's not really a hill. It's a flat plane. So we connect those 2 dots and we're good to go. It's nice when we have 2 numbers here because then we can plug them in, get 2 coordinates, like we did, these 2 guys. Plot those 2, and then just connect them with a line. We don't have to do what we did last time where we only knew this point, and we had to use the slope to figure out which way we were going, right? We had to pick between the right side or the left side. This is much easier because we can just connect them. So it's nice when we have 2 numbers to plug in. Unfortunately, our next one only has 1 number again, 6. So we'll have to use the slope. The first thing we do is we take that number and we plug it in. And when we plug it in, we get -1/3, and instead of x, we have 6 because we plugged it in for x. Now we do some math. Now, remember, multiplication is saying of, so we're really asking 1/3 of 6, which is 2. Another way to think of it is to say, look, I can either times by the top or divide by the bottom. Either or I can do in any order, but I have to do both of them. So what that means is I can divide by 3 first and then times by 1, or I can times by 1 and then divide by 3. Either way is pretty easy. I'm going to divide by 3 first. 6 divided by 3 is 2. And then that -1 is what we need to multiply by. So 2 times -1 is -2. So this equals -2. So we plugged in 6 and we got -2. Now again, we don't have another number to plug in. Otherwise, we repeat the process with whatever number this was. So we have to take this coordinate and we have to plot it. It's going to be an open circle again because, again, no line underneath. So 6, comma, -2. Let's see if I remember to do an open circle. So here's 6, comma, -2. 1, 2, 3, 4, 5, 6, comma, -2. Open circle. Now again, we don't have 2 dots to connect like we did for this one, so we have to look at the slope. So let's look at the slope here. The slope is -1/3. So we're going to go down 1/3. If we do that, down 1/3, we get this. Now, we don't know whether we want the right side or the left side yet, so we have to put our other option, up 1, back 3. So here's the line. The question is, do we want the right side or the left side? And the way we figure that out is we look up here. X is greater than 6. Well, here's 6. Greater than's to the right, so we want this side. So we want this side of that line. And notice, the ones that go on forever in one direction are ones that only have 1 number to plug in, because that's only 1 boundary. This guy stops at 6, right here, but keeps on going forever in the other direction. This guy stops at -4. -4 stops right here, but goes forever in the other direction. Because we have 2 numbers, we have 2 boundaries. So there's no arrowhead needed. They stop between these 2. So that's how you graph a piecewise function. You take the number here and you plug it in. You get your coordinate down here, and then you figure out which way you draw your line based on the slope. If you have 2 points, well, it's really easy. You plug in both points, plot them, and connect the dots. That's it. So what if they give you the graph and they tell you to make the equation? So what if they give you something like this? Zoom in a little bit. So what if they give you, let's do our dashes really quickly. something like this to this connected. And maybe they give you something like this and this connected. And over here for our third one, doesn't always have to be 3, but typically it is. This to this. Connected. Well, as you can tell, we've got 2 boundaries for each of these. And this one goes off to the right forever, so it's only going to have 1 number. So let's zoom out a little bit. Let's write the equations. F of x is going to equal a couple of different ones. What I like to do is do the domain restriction first. So let's call this the first one, the second one, and the third one. The first one, if you look, has a domain restriction between -3, that's right here, and 4, 5, 6, -6. So that's what it's between. It takes place between these guys, right? So the domain restriction for this, when I write it, is going to be -6 on the left and -3 on the right, just like this. See how -6 on the left because it's a smaller number? And in between them is x. And I write my little less than signs. This says x is greater than -6. Here's -6. Greater than to the right. And x is to the left of or less than -3. Here's -3. To the left is that way. So that perfectly outlines this little area that this part of this line segment takes place in, right? So that's the domain restriction for this one. It's between -6 and -3. For number 2, it looks to be between -3 and whatever this is. Looks like 2. So we write -3 on the left and 2 on the right and x in the middle. And again, we do this. And for this one, these are filled in. So we're going to do a line underneath to show that. And that's our domain restriction for number 2. X is between -3 and 2. Between -3 and 2 is where this guy takes place. And then between 2 and, well, infinity. So I'm going to write 2 over here. X is greater than 2. So anything greater than 2. Here's 2. Anything greater is to infinity and beyond to the right. So I don't have another number to put right here, because there's not another point where it stops. This is an arrowhead. It goes on. So those are the domain restrictions. Now let's write the equations. The equation for number 1, well, first we need to find the slope. So let's zoom in and take a look. The slope appears to be down 1, 2, 3, and over 1, 2, 3. So down 3 over 3, otherwise known as down 1 over 1, or -1. So our slope is -1. So I'm going to write that. -1, x. And then the y-intercept, I have to continue using the slope, down 1 over 1, down 1 over 1, down 1 over 1, until I see where it would hit the y-axis. And it would hit it at -2. So the equation of this line is -x minus 2. For the second one, we can find the slope pretty easily between these 2 points. It's up 2 over 1, 2, 3, 4, 5. So up 2 over 5. So 2/5 x for this one. And the y-intercept, well, it looks to be 1, 2, 3, 4, 5 right here, which is a good estimate, and I'll accept that for now. But another way to think of it is, look, we've gone over 1, 2, 3 times. So if we go up 2 over 2/5 3 times, how many fifths will we have gone up? Well, we'll have gone over 6/5 times. So it turns out this is just a little bit above that mark, because 6/5 is a little bit more than 1. So from here to here is a little bit more than 1. In fact, it's 6/5 more. So really we're talking about 1, 2, 3, 4, 5, and an extra 1/6. So that point right there is at 5 and 1/6. To write that as an improper fraction, how many fifths or how many sixes are in 5? How many sixths? Well, there's 6 sixths in 1. So in 5, there should be 30 of them. So 31 over 6 is the same thing as 5 over a 6. So the y-intercept here is 31 over 6. Again, would I have accepted you to say it was 5? Yeah, sure. It's close enough. But that's the exact one. This last one, down here, number 3, we need to find the slope. Well, luckily, we have a nice little point right here on this line. So we can find the slope by going up 1, 2, 3, 4. And it turns out we also go over 1, 2, 3, 4. I love that bell. 4 divided by 4 is just 1. So the slope is 1, otherwise known as just 1x or x. So now we need to find the y-intercept. So if we extend this out by continuing to go up 1 over 1, we'd never hit the y-axis going this way, right? So let's go back 1, down 1, the opposite, to see where we'd hit. Well, this one's not so bad. We would hit here. So where is that? Minus 1, 2, 3, 4. So the y-intercept is at minus 4. So the first step is to find the restriction, the domain restriction, between -6 and -3. X is between them. Between -3 and 2, for this guy, x is between them. Closed circle, so lines underneath them. This one, from 2 to, well, infinity. So starting at 2 and going to nothing, right? Goes off forever. And this is no line underneath, unlike these guys, because this is an open circle, whereas this one was closed. So those are our domain restrictions. And then the equation, we have to find the slope between the 2 points and where it would hit on the y-axis. This one had a slope of down 1 over 1, so I just kept doing it. And eventually I realized it would have hit here. So a slope of down 1 over 1 and a y-intercept at -2. A slope of down 1 over 1 and a y-intercept at -2. The second one was kind of a pain because it was up 2 over 5. Oh, whoops. The second one was up 2 over 5. So I wrote that as my slope. But then the y-intercept was a weird fraction, right? It was just a little bit above 5. I'd accept 5 for now if you want to estimate that. That's a little bit of work. And then the last one, number 3, I did the slope and found out it was 4 over 4, also known as 1. So just 1x. And the minus 4 comes from where this would hit the y-axis. Again, if we do up 1 over 1 forever, it would never hit the y-axis that way, but I can see where it would hit if I were to extend it this way. It would hit it here, which is at minus 1, 2, 3, 4. So the minus 4 goes here. So that's how you write the set of equations to represent a piecewise function like this. Notice that the ones with 2 numbers on the sides have 2 ending points, whereas the one with only 1 number only has 1 ending point. We saw earlier that with a piecewise function like this, you can have horizontal lines. And that's when the equation is just the number where it intersects the y-axis. So this hits at 1, 2, 3, 4, 5, and that's the number that goes there. There's no number to put next to x here like there is for this one because the slope is 0, right? When you have a hill that has 0 slope, it's not really a hill, it's flat, just like this line. And we don't need to write 0x plus 5 here. 0x is just nothing. 0 times anything is nothing. So we just write the 5. Anyway, that's a quick review of piecewise functions. Best of luck on the test next Friday.